These are the notes that go over finding derivatives. And this is what we talked about in class. If you have a polynomial equation, there are two rules that you have to follow to get the derivative. The first rule is to take a look at the exponent and to bring it down and make it a coefficient. And so when you bring it down, if there's already some other number there, you just multiply. The second rule that you have to follow is the exponent gets reduced by 1. So let me show you. The derivative down here, and this is the notation for derivative. It's a function notation with a little 1 above the f. It reads f prime of x, and this is the derivative. So to find the derivative, let's follow the two rules that I talked about. So you bring the exponent down and you get n times whatever number is there. So n times a, that becomes the new coefficient. And the exponent, it goes from n, it gets reduced by 1, so n minus 1. And you do this for all the terms in the original polynomial. So you just follow the pattern. Okay, so let's talk about this example here. F of x is equal to 3x to the 6 minus 2x to the 4th plus 7x minus 2. All right, so since the key is working with the exponents, I'm going to rewrite the expression, each term, rewrite it in a way that I can see the exponents for every x. Okay, so we have 3x to the 6 minus 2x to the 4th plus 7x to the 1. Let's put a 1 there. Minus 2. The 2 does not have an x over here in the original equation, but it's okay to add or to put an x to the 0 there, because x to the 0 is equal to 1 anyway, so I'm not really changing the problem if I do that, the equation if I do that. So I am allowed to do that. So x to the 0 is okay. Okay, so now every x has an exponent, and then I begin the two rules that I talked about. Okay, so here we go. The derivative f prime is equal to, bring the 6 down and multiply. So 6 times 3, well, that's 18, and the x, instead of an exponent of 6, gets reduced to 5. So 18x to the 5th power. Okay. Okay, let's move along. The second term, we bring the 4 down, so we get 4 times negative 2x. 4 times negative 2, and the 4 gets reduced to a 3. Okay. Next term, bring the 1 down. 1 times 7, x to the, instead of a 1, gets reduced to 0. Okay. Next term, you bring the 0 down, so you multiply 0 times the negative 2 that is there. And the x, the exponent on the x, from 0 gets reduced to a negative 1. Okay, let me simplify the expression. So 6 times 3 is 18x to the 5th. Negative 4 times 2 is negative 8, x cubed. The x to the 0 is 1. So it doesn't change anything, and then I am multiplying the 7 times the 1 that is here, so it's just 7. Okay. Now, what about the x to the negative 1 there? Well, when you bring the 0 over to multiply the 2, it multiplying by 0 makes the that term disappear, so that's gone. So I don't have to worry about it. As a matter of fact, every time that you have a number without any x's, it'll always disappear because of that reason. You were multiplying by 0. So, okay, so let me simplify this. 18x to the 5th minus 4 times 2, 8x cubed, plus the 7. And so this is the derivative formula. In other words, it's also known as the slope formula. Okay. So this, if it were if this curve was a straight line, the slope would be just rise over run, the formula that you guys learned in Algebra 1. But because now we're dealing with a polynomial expression or equation, it's more complicated than just rise over run. And so I have my formula there. Okay. Now the second question that I'm asking here in the problem is to find the slope at x equals 1. So find the slope at that specific location, x equal 1. So to do that, we plug in x equal 1, we plug in 1 to f prime of x, this equation. So we just plug it in, and we calculate, and we simplify, and evaluate that, and we get 17. So the slope at the specific location of 1 is equal to 17. And the slope is the same thing as velocity in dealing with problems that that involve distance and time. Okay, so that's the velocity, that's the slope, and this is the derivative. It's all the same thing. Okay? All right, part C. Find the max and min. In class, we talked about how using calculus, specifically derivatives, can help us find the high points and low points in our curves. And to do that is we note that the slope at the peaks, this little line, is the rise over run is 0. It's 0 in every peak, and it's also 0 rise over run. It's a horizontal line, as you can see, horizontal line. It's also 0 at the valleys. So to find this place, that specific x that gives me the high point, all you have to do is find where the velocity or the slope, where the slope is going to be 0. And so another word for the slope is f prime of x. Set that equal to 0 and solve. And whatever we get for x, that will be the place that gives me the high points or the low points. Okay, so here it is. Here's the equation that you are to solve. F prime, right there. Set that equal to 0. Okay, and solve. Solve whichever way you can, either synthetic division, sometimes just a quadratic formula, sometimes even just factoring, and using the zero product property will get us that answer. Okay, so this is the notes. Now, I'm going to discuss the problem. Problem number 1 in the assignment that I gave out. Okay, so I'm going to follow. This time I'm going to work everything out here. Okay, problem number 1. So let me rewrite the expression or the equation, just making sure that everything has an exponent. Every term has an exponent to make things a little bit easier. The 6 is by itself, so I'm just going to put a x to the 0, which is 1. And now I'm going to find the derivative by using the two rules that I talked about. Bring the exponent down, so 2x, and the 2 gets reduced by 1, so that becomes a 1, minus, bring the 1 down, 1 times negative 5 is just a negative 5, x to the 0 gets reduced, and then the last term, bring the 0 down and multiply times the 6, well, that's just 0, so I don't have to worry about that term. Okay, let me simplify this. This is equal to 2x minus 5. Remember, x to the 0 is not 0. X to the 0 is 1. So then this is my derivative. Okay, so that's the answer to part A. Part B now. Find the derivative at the specific given point. Okay, x equal 1. So we just plug in the 1 and work it out into f prime. Okay, so let me simplify that. 2 times 1 is 2 minus 5, which is equal to negative 3, which indicates a negative velocity or a negative slope. And that's the answer to that. That's done. Let's go on to C. The question is, find the x value for which we get a maximum or minimum, so high point or low point. And as discussed previously, we simply take the derivative for f prime and set that equal to 0 and solve. Okay, so the expression we got was 2x minus 5. We're going to set that equal to 0, and let's solve. We get 2x is equal to 5, x is equal to 5 over 2, which is equal to 2.5. And that's where we get the high point. Now, let me show you how calculus indeed works, how this is the right answer. The original problem is a parabola. And we learned earlier that to find the vertex, the high point or the low point, depending on whether the parabola is facing, if it's right side up or facing or flipped over. But anyways, we found out that to find the vertex, we had a little formula, negative b over 2a. And so let me show you what we get when we when we find the high point or the low point using the method discussed before earlier in the year. Okay, so we have negative b, so we have a minus 5 divided by 2 times a is 1. And let me simplify that. We get 5 over 2 or 2.5. And as you can see, it's the same answer that we get over here using calculus. So why not just stick with the negative b over 2a if we get the same answer? Well, the reason is that when we take a look at problems like number 2, this is a power 3. Let me zoom in. This is not a quadratic, and so the negative b over 2a will not work in this situation. And this is the power of calculus. Calculus, finding the derivative, will always work whether the polynomial function is a quadratic, a cubic, to the 3rd power, 4th power, 5th power. Using this method will always work. Okay. Now the last thing that I want to say is that in problem number 2, the derivative, and I'll go ahead and start that method here. Let's start the problem here. Okay, let's find out the derivative. We get 3x squared minus 8x to the 1 plus, bring the 1 down, multiply the 5. That's the derivative. This is the answer to part A. Part B, we find f prime of 2, and you can just plug in the 2 into the x's and work it out. Part C, we go back to the derivative and set it equal to 0. Okay, well, in solving this, we're not going to get the single answer that we got over here. We're going to get 2 answers because it's a quadratic. And if we can factor it, you will see what the 2 solutions are going to be. Okay, I believe that's the right factorization. The right factors are going to be 5 over 3 or x is equal to 1. Okay, so sometimes you do get multiple solutions. All right. Okay, so this is the procedure for finding the x value that gives us the highest point. Now, if you do want to find the complete solution, like the x and the y, or the vertex in this case, you take the 2.5 and you simply plug it back into the original equation, and then you get the complete solution with an x and a y. Now, in problems 1 through 8, I'm not asking for this y value, only the x value. Okay, so that's how you do problems 1 through 8. Let me discuss an application that goes along with that. Okay, this is a problem in our textbook, but it's here on the worksheet that I passed out. And so let me discuss the problem here and show you how using calculus we can be very valuable here. Okay, so it's a maximum revenue. It's a problem about making money here. Okay, so the total revenue are earned in thousands of dollars from manufacturing a handheld video game or video games is given by this equation here. So where P is the price in dollars of the video game. So here we have a manufacturing company that is making video games and wants to know what price would lead the company, what price for the video game will lead to the biggest revenue, the most money. And okay, so question A says find the revenues if the price of the video game is $20, $25, or $30. Okay, sometimes the high number here will not necessarily yield the highest revenue, because maybe the $30 is way too much for a video game and maybe not that many people are going to buy it. But anyways, we can figure that out exactly how much revenue it's going to bring in if we simply plug in these values, the 20, 25, and 30, into the original equation there. And that's what I've done here. 20, 25, 30, we plug it in, and this is what we get, these figures. Okay, as we can see, 25 yields the highest revenue. Okay, but the company now knows that 25 is better than 20 and 30 in terms of bringing in money. But is it possible that the company could bring or do a little bit better by charging $25.30, or maybe $28, or maybe $23, or something different than 25? Possibly. Okay, so for the answer to that, we're going to use calculus. Okay, and that is, we're going to find the high point and the low point, or the low point, by using the derivative. Okay, in this case, it'll be a high point. So we're going to find the derivative just like we did previously in the previous problems. So let's start the process. Bring the 2 down and multiply. So negative 50p plus, bring the 1 down and multiply. 1200. So this is the derivative. If we set that equal to 0, we get the high point. So as you can see, I'm solving it, and I get P, or a price of the video game, to be $24. So this is what's going to yield the highest revenue. Not 25, not 30, not 20. 24 will be better. And I'll show you in a second. All you have to do is take this 24, plug it back into the original equation, and that's what I've done here. Work it out, and you can see that 24 indeed gives the highest money, the highest revenue. So to finish the problem up here, the interpretation is that at a selling price of $24, which we got here, the revenue is highest at this number there, this dollar figure. Okay, and that is it.